In this module, we will learn about the various principles of computer-aided design or CAD and will also be performing an experiment in the simulation software. Computer-aided design is the use of computers to aid in the creation, modification, analysis, or optimization of a design. It is an important industrial art extensively used in many applications to improve the productivity and quality of designs. CAD is used by engineers and designers in many ways depending on their profession. CAD is one part of the whole digital product development activity within the product lifecycle management and is used together with other tools like CAE, FEA, CAM etc. These are some of the CAD software widely used in the industry. As many of the CAD software are paid ones, most people use it for personal projects or as a hobby, since the free ones available are for non-commercial use only. The following are some advantages of using CAD over traditional methods. Number 1, it increases productivity as CAD enables developers to work more quickly, cut production costs and ultimately, complete projects more quickly. Number 2, it reduces errors. With manual design, errors typically arise while drafting bills of materials. One of the advantage of CAD is that this risk is nearly averted, as zero manual input is required once a drawing is made. Number 3, it improves quality. CAD software improves the quality of the design as it allows designers to return to the drawing board in case of errors. Saved drafts and designs can be referenced easily to address any potential mistakes. Number 4, it enables information sharing. CAD programs catalog changes and design histories. CAD files can be shared with partners and reviewed with teams to double-check details. In this section of the module, we will be performing the experimentation in the simulation software called Altair Inspire. Our task is to design a spur gear in the CAD software. A spur gear or straight-cut gear are the simplest type of gear. They consist of a cylinder or disc with teeth projecting radially. The tooth faces are straight and aligned parallel to the axis of rotation and their cross-section usually isn't triangular. A design procedure of simple spur gear is demonstrated using Altair Inspire CAD software below. Step 1, this is the screen we will encounter when we open Altair Inspire. Here we will have to select one of the three planes, X, Y or Z. For this demonstration we will go on the X plane. Step 2, click on the new sketch to initiate the designing process. Step 3, draw a circle of 100 mm diameter using Circle tool. Step 4, go into the Geometry tab and extrude the circle 20 mm using Extrude tool. We can also change the color of our model by right-clicking on Model in the Model tab at the left of the screen. Step 5, again go into the Sketch tab and make a new sketch. This new sketch will be a construction line. A sketch can be converted into construction only by right-clicking on the sketch and selecting Construction. Step 6, to make the tooth of the gear, sketch a half tooth and then mirror it by using the Mirror option in the Sketch tab. There, click on the Curve button, select the entities to be mirrored then select Axis, and click on the construction line. As we can see, the tooth is created for the gear. Step 7, extrude the tooth 20 mm but in opposite direction and mark it as New Sketch in the Extrude option. Change the color to similar to that of gear. Step 8, now to make multiple teeth in the gear, we will use Mirror command in the Geometry tab. Click on the Mirror option and specify the number of teeth, 10 in this case, and select equal spacing then click on the Combine buttons. Step 9, create a hole in the middle of it by making a new sketch. Select the gear we made. Make a circle of 30 mm diameter. Use the Pull/Push option in the Geometry in the setting to create a hole.
Hello, this is a tool capture video on computer-aided design. The objective of this video is to demonstrate the designing process of a spur gear using CAD software. We will be using Altair Inspire for this purpose. A spur gear or straight cut gear are the simplest type of gears. They consist of a cylindrical disc with teeth projected radially. Wherein the gear at 90 degrees from the shaft length to the tooth face are straight and aligned parallel to the axis of rotation. These gears are usually used in mechanical components, also in the gearboxes of vehicles. This is the home screen of the Altair Inspire 2022. We'll be using this software to make spur gear. As you can see, we have multiple tabs over here at the top. We'll be using them to initiate our design process. First, in the sketch tab, we have to make a sketch. Then we'll project it into a 3D model. To initiate the drawing, we have to go in this new sketch tab. Here we have multiple planes to choose from. We'll be selecting one plane and then proceeding with it towards sketching. After we made the sketch, we also have multiple shapes to draw, like line, points, and polygons, rectangles, circles, ellipses, arcs, spines, and we can also assign dimensions to our sketches. We also have some trim break commands. We can also extend some certain lines and splines. We also have fillets and offset and mirror command. In the geometry section, we can create a 3D model out of our sketch using the extrude and push and pull commands. Also pipe, and we can mirror the entities. We can mirror the selected entities, so which makes the designing process very much easier. We also have the circular pattern and linear pattern commands to make multiple entities out of a single one. We also have some draft commands, patch, booleans, slice, and many others. We'll be only using these commands to make our spur gear. Thank you.
Now your task is to design a cylindrical shaft for the spur gear we made using Altair Inspire. Feel free to contact your instructor or mentor in case you have any doubts or questions. Thank you.